Hey everyone, welcome to another Python video. Today we're going to be talking about data types. So data types are just ways of storing information in Python, and these kinds of information are stored in variables. So we're going to go over these data types and what they do. So the first subtype, I guess, is the text type. Now there's only one text type in Python, and that's a string, str. Uh, So in order to make a string, we would use single or double quotes, right? I'm going to use double quotes for this example, and we're going to use something like hello world, because that's pretty much everyone's first print statement in Python or any programming language for that. So hello world is an example of a string. Inside of a text type, we would have pretty much any kind of text that you could type on your keyboard, and we call these kinds of text strings because they are strings of characters. So uh, you might be noticing that I'm putting this hashtag str at the end. This is like the way to uh, get the constructor form of the data type. So another way of writing x equals hello world would be x equals str hello world, like that. But I also need the quotations. And you're going to be seeing this for a lot of other data types, but I'm not going to write all of them out. Uh, they'll just be on the side over here. So that's our first data type. The next one is going to be our integers, floats, and complex. These are going to be our numeric types. So numeric type. So the first one, we're going to do x equals um, 5 or something, right? This is an integer. And integers are basically numbers that are positive or negative, but are also whole numbers. Or, well, whole numbers that are either positive and their negative counterparts, because technically whole numbers can't be negative. And then also zero. So, things like -1, -2, 0, 1, 2, 3, 4, etc. So that is an example of an integer. The next one would be the float. We'll use something like uh 4.56. That's a float. And floats pretty much cover all real numbers, right? Rational real numbers and irrational real numbers. Anything that can be expressed or at least approximated by a decimal. So those are floats. And finally, to uh talk about complex numbers, we're going to use the complex data type. This is something like 1 plus 8j or something like that. You might notice that we use j instead of I. That's like electrical engineering convention because usually you use I for current. But also when you're graphing things and talking about vector notation, usually j is the second component or the imaginary component. But that's why we use j instead of I for the complex numbers, but pretty much same thing. Uh, and if I want to use the constructor function to initialize these variables, I would use like int, float, and complex. So yeah, something like this. And also, let's rename everything so that way it fits the data type. So here we're going to rename this S. This should be I, and then F for float, and then C. So, okay, so that's pretty much it for the numeric types. Up next are the sequence types. And we got three main sequence types here. We got the list, we got the tuple, and we got the range. So the list is basically a list of variables, right? We would put various data types in here. So like maybe something like 5, 4.56, 1 plus 8j, true, um, the capital letter A, and then you can have like other things in here as well. So that's a list. It's like a list of data types, as the name suggests. And similarly, a tuple is very similar to a list. We're going to just copy paste everything here. Yeah. Except we use parentheses instead of these square brackets. And the difference between a list and a tuple is that a list is mutable. What that means is that it can be changed. So I can add things to a list or remove things from a list or change the individual values. With a tuple, it's immutable, which means I basically cannot add or remove items. Um, and yeah, that's pretty much the difference between a list and a tuple. Range, we use the range constructor, and we can put various items in here. So like, let's do something like four, 9, and then 2. So range is something that you'll probably see more often when you're using for loops. But the idea behind a range data type is that it returns a range of integers, right? So here we set our start integer to be 4, and then we want to go all the way up to 9 with a step of 2. So basically, we're counting every 2. So what this range will return would be something like, or actually, we can just print out R, then see what happens. Oh, okay, maybe not something like that, but the idea behind the range is that it'll print out like 4, 6, and then 8, and then it'll stop there. So inside of this range function are these 3 values. And that's very helpful when we talk about for loops. So yeah, I think that's pretty much it for the sequence types. Uh, Up next are going to be the mapping types. And there's really only one of these. That is the dictionary. And the idea behind the dictionary is, well, you use, it's kind of like a regular dictionary, right? Uh, you pair two items together. In a dictionary, that would be the word and its definition, right? And it's kind of a similar thing here. You can pair two items together in a dictionary. So as an example, here we're going to use the curly brackets. And then let's pair like someone's name and their ages together, right? So we're going to do something like Adam, and that's paired with his age, which is 78, and then Bob with his age, which is like 2, right? So that would be an example of a dictionary. And like a list or a tuple, it doesn't have to be the same data types that are being paired in a dictionary either. So if I wanted to do something like true and then pair that with 1 plus 8j, I could do that as well. One other thing to point out here is that the dictionary constructor function is a little different. So if I want to use the constructor function dict, uh, I would need to use some variable names inside. So here I can't use Adam as I can't just like completely copy paste this. You'll see I get some errors, invalid syntax. What I need to do instead is that I need to use variable names. So I can do Adam equals 78, Bob equals true, 2, and then instead of true, since true can't be a variable name, let's do something like lowercase true equals 1 plus 8j. Yeah. So this is how you would use the dictionary constructor. It would have variable names instead of like these what like the keys instead. And by the way, for a list and a tuple, similar ideas, but instead we're going to be using double parentheses for each of these. So if I want to do make a list with the constructor function, I would just use double parentheses instead of square brackets, and same thing for the tuple. All right, I think that's pretty much it for the mapping types now. So we're going to move on to the set types. There are only two of these, and these are going to be your set and frozen set. So since S was already used, we're going to use SE for a set. And a set is pretty much the same thing as a regular list. The only difference is that you're going to have no duplicates. You cannot have duplicates in a set. So we're going to just copy paste it. And yeah, that would be a set. For a frozen set, we're going to use FS. And yeah, it's basically the same thing as a tuple, except there are no duplicates. So same thing here. But we need to also use the frozen set constructor. This is like one of the few data types where you actually need to use some constructor in order to actually use a data type. So this would allow us to use the frozen set data type. For a set type, you just need to use curly brackets. You don't need the set constructor, but if you wanted to do the set constructor, you would just use double parentheses. So that's pretty much it for set types. And the next thing we're going to be talking about is the Boolean type. Now, the Boolean type can only take on two values. Those are true or false. So we're going to do B equals true for now. But yeah, they can only take on two types. And this is very useful for if statements and while loops. I think that's like the most famous application of Booleans. And the idea behind it is that it's used a lot for like conditionals, right? Like if something is true, then do this other thing. So that's what Booleans are used for. And if you wanted to convert something to a Boolean, you would just use the bool constructor. So yeah, that's pretty much it for Booleans. And I guess our second to last data type is the binary data types. We have three of these, byte array, bytes, and memory. So let's go over each of these. All right, so with B, since we already used it, we're going to just use by. And bytes is very similar to a string. So we just do B, and then here's our string over here. We're going to just put hello world in here. But the difference between bytes and a string is that bytes is more closely related to the use of ASCII. So you might have seen this table before where we like pair a number with a character. So like for example, 65 is the capital A. So if you wanted to use a program, or if you want a program that deals heavily with ASCII, uh, bytes would be a better option for you to use rather than string. Bytes array is very similar to bytes, except um, except bytes array is actually mutable. So like if you remember from lists, mutable means that we can change the value basically, right? So byte array you can change, while bytes is immutable, which means that you cannot change it. So here we're going to put something like, I guess, hello world as well. And then finally with memory view, um, memory view is just a way for us to um, get the ASCII code of each character inside of a bytes or byte array. So like if I wanted to get the ASCII code of like BA0 or something, then it will return 72 because H is 72 on the ASCII table. So in order to make a memory view, we would do memory view, and then inside of the parentheses, we would put either a bytes object or a bytes array object. So I'm gonna put BA in here, a bytes array object. So yeah, that's pretty much it for the binary types. Oh, actually, if you want to use the constructor function for bytes, it's just bytes, um, like that. but more commonly you would just use B and then put the string next to it like that. Okay, so that is actually everything to talk about binary types. And we're going to move on to our final type of sorts, the none type. Uh, None isn't really a type. It's more like there's nothing inside of it, right? So we just set our variable equal to none. And the idea behind it is that it's basically empty. It's completely empty. It doesn't even store zero or an empty string or anything. It's just, it has no data type and it has nothing inside of it. So that's pretty much what none is. And as such, none doesn't exactly have a constructor either. So there's no constructor to show here. But yeah, I think that's pretty much it for our discussion on data types. But now let's try using that knowledge that we learned about data types to some more practical applications, I suppose. So here we got some Python data type and operator exercises that we can do. So we're going to just go over each of these one by one. All right, so the first program is to write a Python program to convert a temperature from Fahrenheit to Celsius. So we would input a degree in Fahrenheit and then return a degree in Fahrenheit equal to some other degree in Celsius. Okay, so first of all, I'm gonna just copy paste all this because I don't want to type all of that out. So we're going to like separate our code a bit. Okay, and then this is going to be problem one. There's 7 problems that we're going to be going over, and this is just going to be a first one. All right, so we're going to just copy paste what we have here. And yeah, so for the first thing is that we need to get the input, right? So we're going to do, first of all, we're going to print out the prompt, input a degree in Fahrenheit. We're going to copy paste that. And up next, we're going to use the input function to get an input. We're going to start at an X because, yeah. So we'll get some input in X, and then we're going to return some kind of output, right? So when we use the input function, uh, it's actually going to be stored as a string. So we want to convert this to a float because a temperature can also be a decimal. So we're gonna convert it to a float first. And then after that, we're going to use the conversion chart to convert Fahrenheit to Celsius, right? So that conversion is basically five ninths of the difference between 32 and the degree in Fahrenheit. So what that is basically we're going to do x equals um, 5/9 like this times x minus 32. So now x will be equal to our degree in Fahrenheit, or sorry, our degree in Celsius. And we should probably store this in a new variable, C for Celsius. And actually, we should change this to F for Fahrenheit. So now that we got our Celsius degree, we just need to print it out. So something like print, um, so 212 degrees Fahrenheit, so that was our input. So in order to combine strings, we need to convert the float into a string first. So that's why I did strf. So we're going to do that plus these double quotes here. Degree Fahrenheit is equal to um, plus str c because that is a float. And then we're going to do another one of these in Celsius. So something like this. So we have our degree Fahrenheit in degree Fahrenheit is equal to C in, this should say degrees Celsius. Um, yeah, so let's run it. Okay, so there might be something wrong here. I'm gonna just comment it out for now. We're gonna comment this out as well. Okay, let's try running it again. All right, so we want to use, what was it again? 212. And then, yeah, it pretty much matches the output. So that is an example of how we use data types and converting data between data types to solve the problem, right? We had to convert the input to a float in order to do the math on it. And then after doing the math, we have to convert it back to a string in order to print it out. So that's pretty much it for our first problem. I'm gonna print out some dashes to like separate between the problem outputs. And up next, we're going to have problem two. Or actually, I'm gonna just erase all of this actually. So problem two. And let's read what problem two wants us to do. So we want to convert inches to meters. Okay. And 1 inch is 0.025 meters. Okay. So similar idea here. We're gonna first print out the prompt, which is input a value for inch. So we're gonna print that out. And then we're going to store whatever uh, our inches is supposed to be in I. I'm gonna actually delete all of this stuff. Okay, so we have I equal to input. But remember, since input is a string and we want to probably convert it to a float, we're going to use float because integers can be, or sorry, inches can be decimals. They don't always have to be. So after that, we're going to convert it to meters. So M equals 1 inch is 0.0254 meters. So I think we will multiply that by I. So 0.0254 times I. And then once we got M, we would just basically print out um, whatever this is. 1,000 inch is 25.4 meters. But instead of putting out 1,000, we're going to replace that with um, I, but we got to convert it to a string. So stri plus inch is going to stop the quotation mark here, plus strm, and then something like this. Yeah, so like some inch is blank meters. That looks good. So I think the input values was 1,000. Let me check that. Yeah, 1,000. So 1,000 inch is 25.4 meters. Yeah. This should probably be inches, but yeah, I mean, we basically got the correct answer. So that's pretty much it for problem two. We're going to move on to problem three. Write a Python program that reads an integer between 0 and 1,000 and adds all the digits in the integer. Okay, so uh, we're going to copy paste the prompt and this thing. So we have an idea of what our output and input should look like. So first we're going to print this out. Uh, get rid of that 565. And yeah, we're going to do something like this. An extra double quote here. And then we're going to need to store the input. So I guess I for integer, or actually let's use n for integer or for number. So our number is going to be um, this time we're not actually keep as a string. So we're not going to convert it. And the reason why is because we need to sum all the digits, right? So in order to do that, the idea we're going to do is we're going to take each character of n and then add those up. So we're going to have our sum variable here. sum equals 0. And then we're going to for loop from for each number in n, like that. So it's going to go through each character in n and sum them up. So we're going to do sum plus equals uh, the integer version of I. Because remember, I is normally a string, so we got to convert it to an integer in order to add it up. So we're converting each individual character into integers, but we're not converting the whole thing to an integer yet. So that should be our sum. And then instead of doing sum str in the print statement, we can also just do sum equals str sum, like that. So now we converted it to a string, so it's okay to add now. So we will just do print the sum of all digits in plus n, and then is uh, I, no, sum. So something like this, but I'm not sure. Oh, I forgot. Yeah, okay. So the sum of all digits in whatever our number was, and since it's a string, it's okay to add plus blank is, and then the sum. So what was the integer digits here? 565. So the sum of all digits in 565 is 16. Yeah, that's right. So that's it for the third problem. So let's move on to the fourth. The fourth problem wants us to convert minutes into a number of years and days. So we want to convert minutes into years and days. Okay, approximately years and days. So what that tells me is that we don't want like 210.38 days or something. We just want to round to the nearest day. Okay, so first of all, as always, we're going to get the input the number of minutes, like that. Yeah, so, and then after that, we're going to store minutes. And since this is, I think we want to store as an integer because there's no point zero at the end, as you can see. So since it's approximately, we're going to just store it as an so integer input. And then we just need to convert minutes to years and days. Okay. So how many minutes are in a day? Well, okay, so there are, sorry, guys, give me 1 second to do. Okay. So I want to convert minutes to days. So uh, we know that there are 60 seconds in a minute. And then, oh, wait, no, I'm converting the wrong way. Okay, there are 60 minutes in an hour. Sorry. So we need to divide by 60. And then after that, there are 24 hours in a day. So uh, canceling that out. So we will need to divide by 60 and then divide by 24. Okay. So our days, the number of days should be equal to minutes divided by 60 times 24. Yeah. Okay. And then to convert days to years, we know that the number of years is equal to 365 days. I'm assuming that we're not counting leap years because they didn't tell us to, but if we have to do that, we'll fix it later. So days divided by 365. So now we got days and years, so we can print out whatever this is. So minutes is approximately, so str min plus blank minutes, so that is approximately uh they want years first? Okay, so they wanted years first. Years plus years and str days plus days. Okay, so let's run it and see what happens. We want this number of minutes. It's not letting me copy paste. Okay. All right, I'll just write it out manually then. 3, 4, 5, 6, 7, 8, 9. Okay. All right, so as you can see, our program did not work as expected. The first thing is that I forgot to convert this to, well, I forgot to convert both of these to integers. So this should be integers, and I think this should also be integers. And then the other thing is that I need to subtract um basically how many days that are taken by the year. So um because the thing is that this 2,400 days, but then we need to remove the 6 times 365. So uh in order to solve that, we would just do days minus equal years times 365. Good work. 3, 4, 5, 6, 7, 8, 9. Is that right? Yeah, that is right. Okay. So yeah, things that was a good example of things not always working the first time. Uh, yeah, that's something you have to get used to in programming. So yeah, always check your work, don't give up, things like that. But yeah, that's pretty much it for this problem then. So we're gonna move on to the fifth problem of this exercise set. Uh, computing body mass index. Okay. First we're going to need to look up the formula for body mass index. Not here. Body mass index. Okay. Okay, so the body mass index is apparently your weight divided by your height squared. And okay, that's pretty much it. Okay, so weight divided by height squared. Okay, so yeah, we're going to get the two inputs this time. So first, we're going to input weight in pounds. We're going to store that in p. Do they want integers or decimals here? Okay, we since we're using decimals, we probably should just use float input. And then we want to get our height in inches. Okay, so we're going to get height in, sorry, I in float as well. And then we want to, okay, so then we want to calculate our BMI. So BMI is uh, our weight or pounds divided by our square inches. So something like this, I believe. And yeah, okay, that should work. And then basically we print out body mass index is STR BMI. We're going to run that. They want us to be 452 pounds. All right. Um, and then 72 inches. Okay. Okay, something's wrong here. I'm probably not doing something right. Am I using the wrong formula? Hold on. Oh, apparently we have to multiply by 703 at the end. Okay. So maybe that'll fix it. 452, 72. Uh, we're getting closer, but not exactly. Right. That is interesting. Let me look up the formula in customary units. Maybe that's the issue. 703. Weight over height in inches. Maybe there's something wrong with order of operation. Another problem could also just be that arithmetic isn't always perfectly exact in Python compared to like say your calculator. So I'm gonna check it on my calculator and see if it's like our issue or if it's just like Python's rounding issue. So 452 divided by wait, so 70. Okay, so we want 703 times our our weight in pounds. So that's 400 divided by 72 squared. Okay, I'm getting the same thing on my calculator. So maybe this is something. Are we not doing something right? Hmm. Okay. To be honest, like it's maybe it's a miscalculation on their end because this is the only formula I can find online. So I'm not sure if the formula is the wrong thing here. So and plus it's like roughly exact. Um, I guess if you guys know anything in the comments, just put it there. But for now, since it's pretty much exact, apart from this, I guess. But if you round, then it's pretty close. So for now, we're going to just put this problem on hold and just move on to the next problem. Okay. Problem six, write a Python program that takes the user distance, the time taken, and display the speed. Okay. Okay. All right. So we want to input the distance in meters, the hours it takes, the minutes, and then the seconds. Okay. Okay. All right. We can do this. So as always, the first thing is going to get our input. So input distance meters. And then do we want to store that? We probably want to store it as a float. Okay. So float. So I guess D equals float input. Then we want to input hours, or sorry, input hours. And then H equals float input. We want to get the minutes next. We're going to store as M equals also float input. Thankfully, uh, H, M, and S could be integers because since you're splitting it into hours, minutes, seconds, there's not going to be decimals. But the thing is that by doing it as a float, we don't have to really worry about converting when we're adding and subtracting, or sorry, multiplying and dividing later on to calculate the speed. So that's why I'm converting everything to float right now. But if you convert it to integers first, that's honestly not going to make it there. So you do whatever you want to do. But yeah, that's just like justification as to why I'm using float rather than integers. Also, it's uh, basically personal preference. Okay, so we got our input now. And then we want to print out our speed in meters per second, kilometers per hour, and miles per hour. Okay. All right. So to convert into meters per second, since we have our meters as D, um, to get our first, I'm going to just do output one because I can't write meters per second as a variable. Or actually, I can do maybe, am I going to use milliseconds anywhere? Okay. All right. I'll just do ms as our variable name. So ms or meters per second will be equal to distance over however many seconds this takes. So we would need to convert hours to seconds, minutes to seconds, and seconds to seconds. So seconds is obviously seconds. There are 60 seconds in a minute, so that would be 60 times m. And then after that, we will do, what is it? So how many hours are in? It's 3,600, I think. Yeah, 3,600 hours. Or sorry, 3,600 seconds in an hour. So I think this should probably be right. And then we're going to just print out your speed in meters per second is blank. Okay, so that'll be equal to STRMS. Okay, so what was it? 2,500, 556, and 23. 0.11691531. Okay, we went a little more decimal places, but that's totally fine. We basically got it. So, okay, so that's right. And then we're going to move on to, what was it? Kilometers per hour. Okay. So in order to convert from meters to kilometers, we would divide by 1,000. And then we would need to divide this further by the time, right? So we want it in hours. So that'll be hours plus, since there are 60 minutes in an hour, we would divide by 60. And then we would divide seconds by 3,600. I think I'm doing this right. Okay. And then we would print out your speed in kilometers per hour. Yeah, is SDR KMH. So we're going to run that 2,500 by 56 and 23, I think. Oh, we forgot the space at the end, but we can fix that. Okay, I think it's pretty much right. Yeah. Okay, so our speed is correct as well in kilometers per hour. And then finally, we got to convert it to miles per hour. Okay, or mph, I guess. So that would be your speed in mph is whatever. And then we're going to have our variable named miles per hour. And we're going to obviously add miles per hour at the end. Delete this period at the end because I don't know what that is. And then we got to convert meters to miles. Okay. So what does that mean? We got to divide by 1,609. So we got to do that. And then copy and paste this hour conversion here. Also forgot to point O's at the end. I guess it doesn't really make a difference since floats and integers, they're both numbers, so they're kind of interchangeable. So you don't have to be as strict about converting, but you definitely do need the str still. So we're going to run this again. 1,500, 5, 56, and 23. Okay, that's probably right. I think like starting towards here, we get into some math errors, but that's not really in our control. So yeah, I think pretty much the problem is solved for here. So we're going to move on to the final problem, where we need to get two integers and then print out the sum difference product average distance of the two integers, max integer and the min integer. Okay, so we're going to delete all this and we're going to start first by getting our input. Input first integer. Let's do n1 for this. This will be stored as an integer, obviously. And then we're going to do the same thing here. Input second integer. And 2 equals int input. Okay. And then here we want to print out the sum difference product averages. Okay. So I'm going to just spend the next couple of seconds just uh, prepping my input, or sorry, output. So I feel like most of these are pretty trivial to the point where we don't necessarily need variables for them. But we're going to just keep it consistent and use variables. So obviously our sum will be n1 plus n2. And we would convert that to str sum because we want it to be a string when printing it out. Difference would be, um, what's the difference between difference and distance? I'm assuming distance is probably like absolute value or something. So Okay, so difference would just be n1 minus n2, right? Yeah, n1 minus n2. So we print out difference of two integers. That is FTR diff. Up next, we got product. We're going to do prod equals n1 times n2. And then we're going to do the same thing, right? Product of two integers plus str prod. Okay, up next, we got average. Average, I'm assuming they want arithmetic average. Yeah. So that would be the n1 plus n2 and then divide by 2, right? Now, obviously, we need parentheses because order of operations. So that would be print average of two integers plus str average. Okay. And then up next, we got distance. It's going to be the same thing here, but distance equals if. And then basically, if distance is less than 0, we're going to convert. Actually, we're going to just multiply it by -1. So, and then we're going to just print it out. Distance of two integers. STR distance. Finally, we got our max and minute integers. Okay. So, what's wrong here? Oh, I forgot a colon. Okay. So, okay. So for the max and min integers, we're going to assume that, um, let's just do two if statements, right? If n1 is greater than or equal to n2, max will print out max integer plus str of n1. And then min integer would be the other one, n2. Oh, and of course we got converted. And then after that, we're going to just basically copy paste this and then flip the order around. So this should be our else statement, else n2 and n1. Okay, that should pretty much be it. So I think it was 25 and 5. All right, so let's take a look. 30, 20, 125, 15, 20, 25, 5. So yeah, as you can see, our program works on the end over here. And yeah, that's pretty much it for all of the data types exercise we've got here. So yeah, thank you guys for watching this video and yeah, continue learning Python and all that. Hope to see you in the next one and thank you.